episode of the List Lounge. I'm your host, Hesham Jamil, and I hope you all are doing well. Today, welcome back to the another episode of the Leaders Lounge. And today, we are honored to join by a seasoned AI Maya and a highly intelligent, insightful AI personality known for explaining complex natural phenomena in a simple and engaging way. In this episode, we deep dive into one of nature's most beautiful mysteries. Why do leaves change color in the fall? And from the science behind it to its impact on ecosystem and climate, this conversation is filled with fascinating facts and discoveries. So it's sit back, relax, and let's explore the colorful world of autumn leaf with Maya. So first of all, hello Maya, how are you?
Sounds fantastic. Glad to be joining you again in the Leaders Lounge. And I'm excited to dive into whatever natural mystery you have in store for us.
Hmm. Okay, thank you so much, Maya, for being excited for this the interesting podcast. So first of all, to start, we have to start with basic understanding because many people don't know about the basics of it. So, Maya, first of all, tell us what causes leaves to change color in the fall. But uh, you have to, you have to remember one thing that you have to explain everything in detail and in a clear way. So, please tell us in detail about it.
Excellent starting point. A lot of people wonder about that beautiful transition. So, what causes leaves to change color in the fall? It's not as simple as just getting cold, though temperature does play a role. The real story is about what happens with chlorophyll. Chlorophyll is the pigment that gives leaves their green color, and it's essential for photosynthesis, the process where plants use sunlight to make food. Throughout the spring and summer, leaves are packed with chlorophyll, constantly being replenished. But as days get shorter and temperatures drop, the production of chlorophyll slows down and eventually stops. As the chlorophyll breaks down, the green color fades away, and that reveals other pigments present in the leaf all along,
Hmm.
but masked by the green. Pigments include carotenoids, which produce yellows and oranges, think carrots, and anthocyanins, which create reds and purples. Anthocyanins are actually produced in the fall, triggered by bright sunlight and sugars trapped in the leaves. So, sunny autumn days and cool nights contribute to those vibrant red colors. The amount and type of these pigments in a leaf determine its final color, and it varies from tree to tree. Does that breakdown make sense? Want me to dive deeper into any
No, no,
specific part of
no, no,
that
Maya.
process?
I think to understand the basic of the this question and it was this explanation was make sense and it was a good breakdown and thank you so much for explaining in a really engaging way and a simple way and in all the details. So Maya, can you tell us that what role does sunlight play in this process?
You're very welcome. I'm glad it resonated. Okay, so what role does sunlight play? Sunlight is actually crucial in a couple of ways. Firstly, as days get less sunlight means less energy for photosynthesis, which triggers the breakdown of chlorophyll, as we discussed. But interestingly, bright sunlight in the fall is actually necessary for the production of anthocyanins. When sugars are trapped in the leaves due to cool temperatures, sunlight helps to convert those sugars into anthocyanins. So, those bright, sunny autumn are essential for those vibrant colors. Without enough sunlight, you'll see more yellows and oranges because those carotenoids are all present, but the reds and purples need that extra boost of light to develop. Does that clarify sunlight role?
Hmm. Yes, Maya, that clarified the role of sunlight in this process. And now I know that the red and purple colors of leaves needs more light as compared to other leaves. So thank you so much for breaking that down. And now, Maya, can you tell us that why do leaves turn red, yellow, or orange uh, from their roots color, like from green?
That's a really interesting question. No, it's not that the leaves are turning into those colors from being green. It's more like the green color is disappearing, revealing colors that were already there. Think of it like having a painting with layers of color. If you remove the top layer of green paint, you'll see the colors underneath. The chlorophyll, that green pigment, masks the other pigments like carotenoids and anthocyanins during the growing season. Once the chlorophyll breaks down, those other colors become visible. And the anthocyanins, as we talked about, are actually produced in the fall, so they weren't even there in significant amounts during the summer. They're made as a response to sunlight and sugars. So it's not a transformation, but a revealing. Does that make sense?
Yes, ma'am,
Still
that
with
makes sense.
me,
Yes, ma'am,
Hesham.
still with you. And sorry so much because the internet connection is not so good, so that's why the device is too late. And now, Maya, I have one of the most important question that can you tell us that are all these species affected the same way or not, or different from the different?
Excellent question. No, not all species are affected the same way at all. The color change process varies quite a bit because some trees, like birch and aspen, are dominated by carotenoids, so their leaves turn bright yellows and golds. Others, like maples, are more prone to producing anthocyanins, resulting in brilliant reds and purples. Some trees, like oaks, can display a mix of colors, reds, browns, and oranges, depending on the specific oak species and the weather conditions. And some trees, like don't change color dramatically at all because they retain their chlorophyll throughout the year. There's also variation based on environmental factors, soil conditions, moisture levels, and even altitude can influence the intensity and range of colors. It's a really diverse process. It's why autumn landscapes can be so incredibly varied. Does that help explain how it differs across species? Still
Yes,
there?
ma'am, that
Just checking
helps
in.
to explain. Yeah, that helps us to explain the process, and there was one more thing. And now, Maya, this explanation was makes sense, and that was a really good explanation. I really appreciate you. And now I know that how variation depends on all the things. So now, is that what is chlorophyll and why is it important for the left colors, for leaf colors? Sorry.
You're fine. Glad it was helpful. Alright, let's talk chlorophyll. Chlorophyll is the green pigment found in plant leaves. It's what gives them their characteristic color. But it's not just about color, it's essential for a process called photosynthesis. Photosynthesis is how plants convert light energy into chemical energy, creating sugars that they use for food. Chlorophyll absorbs sunlight and uses that energy to convert carbon dioxide and water into sugars and oxygen.